All right. Section 4.8, the end of chapter 4. The only thing left to do with our fractions is let's just throw them into an equation, and let's just solve an equation with some fractions. These are just going to be linear equations. We're not really changing up necessarily the overall form, so we're essentially going to be doing honestly two options. So this particular video will focus on just using our sort of regular 3.4 techniques to solve. So in some sense, not really changing our strategy at all, right? It's just that okay, well, now the new piece of information is that we have to deal with fractions when we solve it. So we don't really need to necessarily do anything new. We just have to sort of deal with the fraction arithmetic as it comes up. So let's just sort of run a couple examples and see what this might look like. We'll start simple, obviously, and we'll get a little bit more complex as we go. So how about something like 1/4 plus x equals, negative 3/5 or something, right? This is about as sort of simple of an equation as we could get. This is really what we would call, essentially a one-step equation, right? We really just need to sort of do one thing to solve it. And that is, right, we're trying to solve for the x, so we just need to subtract this 1/4 from both sides. And so the sort of new stuff here, right, is I need to actually, right, when I do this subtraction, I have to put a little bit of work into it because I have to do common denominator stuff. I can't just sort of quickly do the arithmetic in my head like I would back in chapter 3. 5 and 4, we're going to use 20 as our LCD. I'll do some of this stuff maybe a little bit fast because we've been doing it now for a few sections. So negative 12 over 20 minus, so just getting bigger essentially, right? So x equals negative 12 over 20 minus 5 more over 20, so then that's going to be in total negative 17 over 20. That's not going to reduce. That's going to be our x. So just a one-step equation here, right? We just need to sort of do the subtraction to solve it for the x. Right, obviously you could do a similar thing if you needed to add to both sides, right? Not really anything too groundbreaking here. One thing that's going to have just a little bit of a new look to it is if I sort of do a one-step equation, but let's say how about 6 over, I don't know, what does it go into 6? Let's do 6/5, I guess. So let's say 3/4 times x equals 6 over 5. So this would be a sort of one-step equation where we need to sort of do a division by a fraction. Again, that's not necessarily a new idea, right? And in some sense, you can write this a lot of different ways. Maybe I'll actually write it in the same way that we've been doing, right? Divide everything by 3/4, and what happens is we sort of make one of our stacks when we do this. So the idea, right, 3/4, 3/4. So what we get here is sort of x is going to be this 6/5 divide by 3/4, and then that's just going to be a flip and multiply times 4/3. A little bit of canceling, right? 3 cancels out, leaves us with a 2. So this would be x is 8 over 5, and that'll be our final. So the one-step type equations, right, we can sort of just do a one move and we get the answer. Addition, subtraction, we still need common denominators. Obviously, that's never going away, ever. As long as we're alive, I guess. That sounds threatening. not necessarily how I meant it. Or, something here like a division, where we're doing, a fraction division. I guess another thing, well, no, we've actually done this before. I was going to say, if you had, x over 5, right, that really is 1/5 times x, but you're just going to multiply by 5. We've kind of seen that before. So let's consider something that's maybe slightly longer. So let's actually put a little bit just more stuff into here. Again, nothing super wild. I'll just sort of throw a couple more numbers in. So how about 2/5 minus 3/4 x equals, I don't know. What else do we got? 3/2? Sure, right? Why not? So do a little bit of each here. We're not necessarily, you'll kind of notice in this section, because there's fractions, the extra work are kind of coming from the fractions a little bit. They're not necessarily going to try to overwhelm you with tons and tons and tons of steps, so I won't necessarily do that in the examples either. The general strategy here, right, from 3.4 is we're trying to kind of get our x terms on one side and the number terms on the other. So what we're going to do is let's subtract this 2/5 over as like a step 1. So that means negative 3/4 x equals 3/2 minus 2/5. So what happens to us here is we have to sort of just do these fraction problems essentially just like as we go, right? So I'm going to need LCD over here. This is 2 and 5, so I'll just use 10. They don't have anything in common necessarily, right? So my LCD here is 10, so we're going to have to do times 2 over 2. I have to do this one times 5 over 5. So this is going to be, what, 15 over 10 minus 4 over 10. So that's going to be 11 over 10. So 11 over 10, I'll carry this back over. Shift my paper up so you guys can actually see what I'm doing. So this is negative 3/4 x equals 11 over 10. That should be 10, of course, right? And again, we're not really trying to do anything super fancy here. We're just sort of doing two of these things together. It's always tempting, right? You see the negative here. It can sometimes make you just automatically jump to addition, but of course this is really negative 3/4 times x. So I'm just going to divide by negative 3/4. And so what that means for me is my x here would be 11 over 10. So we'll multiply, right, by the reciprocal. The negative is kind of just along for the ride. I'm not necessarily trying to do anything fancy with it. I kind of just shifted it up onto the 4. I'll just sort of generally keep it up in my denominator. A little bit of cancellation here, right? 10 would be 2 and 5. 4 would be 2 and 2. 2 cancels 2. Keep your negative. Don't lose this. This would be negative 11 times 2 over 5 times 3. So this looks like x is going to be negative 22 over 15. That's a pretty random number. That's about as random a number as we're going to see for the most part. Just so we've seen it, I'm trying to think of, what could we do to even expand these out and get them to be a little bit longer. We could do a little bit of distribution type stuff. And actually, I'll show you one of the things that the homework does. Is they'll do a distribution with a whole number. So say you have 2 times, 1/3 minus 5/6 x plus, 5/2 equals, gosh, could be anything. How about 13 over 12. There's a lot of different fraction numbers, right? There's a lot of different fractions kind of floating around there. That's fine. Let's just sort of attack this kind of one piece at a time. In the next video, we'll do 2 videos for this section. So in video number 2, we'll talk a little bit about an alternate strategy where you would look across all the fractions for one one kind of master common denominator across everything. But for now, we'll just sort of take everything one step at a time. So let's just do like 2 times 1/3 and 2 times 5/6. Let's just like distribute this. Part of the key here is, right, treat the 2 like a 2 over 1. You're going to multiply by some fraction stuff. Oh, the other thing, right, is, so it's, 5/6 times x. There's no real reason in this case, in theory, you could like attach the x to the numerator. I think that's actually not going to be super helpful here, so that's why I'm not doing it mostly, because it's not helpful. In theory, you could, but it's not really going to gain anything. As we go through this, right, 2 times 3 is 2/3. 2 in here, right, this would actually cancel. So then this would be minus 5/3 x. Tempting to do thirds and thirds, but of course one is a number and one has an x on it. So plus 5/2 equals 13/12. So we have a couple things here we can combine. Let's look at 2/3 plus 5/2. That's going to require some common denominator stuff across those two. We would use 6 times 3 and times 3 times 2 and times 2. Oops. And if I kind of rearrange this a little bit, right? So this is kind of negative 5/3 x. This is going to be plus 4/6 plus 15/6 equals 13/12. So again, conceptually, right, we're not really doing anything different from what we did in 3.4. It's just the arithmetic steps kind of stretch out a little bit longer. You know, it is what it is. It's fine. We'll live. 14 and 15, right? So now these have common denominators. So this is 19/6. We weren't really picking these numbers to try to get them to be particularly nice together. So they're not. So we have the x over here. Let's subtract our other number to the other side. So we get all our numbers on the right. We'll keep our negative 5/3 x on the left. What are we going to get here? This is going to be, so negative 5/3 x equals, so 13/12 minus 19/6, right? Our common denominator here, 12 and 6, well, that's going to be sort of times 2/2, right? We're just use 12. I could do 6 times 2 is 12. We'll deal with that. So negative 5/3 x carries down 13/12. Oh, maybe I should have just written this over on the side. That's okay. 19 times 2, 38/12. 13 minus 38. Oh, these numbers, they're so amazing. 13 minus 38 would be, so negative 25/12. So we've got this sort of negative 5/3 x equals negative 25/12. Let me rewrite this. One thing that will happen here, right? So it's a negative times x equals a negative number. So the x here is actually going to be positive. This would be, right, division by negative 5/3. So then this, right, becomes negative 25/12 times negative 3/5. Oh, this is actually going to clean up pretty good, right? 5 goes out, 5 times 5. 3 goes out. Gosh, what are we left with? Negative. No. Negative times negative, right? So negative times negative is going to be positive. 5 times 1 over 4 times 1. So this is going to be positive 5/4. So my final answer here, x is positive 5/4. A little intimidating. That obviously took up, one entire sheet worth of writing. Partially that's just me not necessarily using my space as well as I could, and just trying to be really generous and sort of write out all the possible steps. Maybe what we'll do in the next video is we'll actually sort of redo the solution for this example, and I'll sort of show you this other strategy. We'll do some other ones. So we'll do one more video for section 4.8.